In this video, we are given actual over 360 rates in the market, and we're trying to compute the actual over 360 forward rate between 138 and 302 days. Okay, so the rates we're given are for 138 days, the rate is 572, and for 302 days, the rate is 651. So our strategy for solving this sort of a problem is first, take the rates and compute the discount factor. Remember, the discount factor is the present value of $1. So we take the rates, compute discount factors. We calculate a forward discount factor by taking the second discount factor, the longer dated discount factor, divided by the shorter dated discount factor. And then we take that discount factor and solve for a rate, generally by inverting the discount factor to rate formula. So generally our formula is given as discount factor equals something in terms of a rate. We invert that formula and we find the rate in terms of the discount factor. Okay, so for actual over 360 rates, the discount factor is given by 1 divided by 1 plus the rate times days over 360. So here it's 1 divided by 1 plus the rate, 5.72%, times the number of days, 138, divided by 360. If this rate had been an actual over 365 rate, that 360 would have been a 365. Now we can look at this formula and we can see where it comes from. Remember, the discount factor is the present value of $1. 1 over the discount factor is the future value of $1. 1 over this formula, 1 plus the rate times the number of days divided by 360. Well, if we invest $1 today, what does it turn into? It turns into 1 plus the interest rate times the number of days over 360. That's how actual over 360 interest rates work. Again, so that's a future value. 1 over that is the discount factor. So we get this formula. So for 138 days, the discount factor is 0.978544. The discount factor is the present value of $1. If I have a cash flow in 138 days, I multiply that cash flow, the size of that cash flow, times the discount factor to find the present value. Okay, the discount factor for 302 days is calculated in exactly the same way. So I'm just copying my formula down. We'll just take a look at it to make sure it makes sense. 1 divided by 1 plus 6.51% times 302 divided by 360. So I have my short dated discount factor to 138 days and my long dated discount factor to 302 days. The forward discount factor, this is our next part, we have discount factor 2 equals discount factor 1 times discount factor 1, 2. Discount factor 1, 2 being the forward discount factor. So the forward discount factor is the longer dated discount factor divided by the shorter dated discount factor, 0.969008. That's our forward discount factor. We now want to compute the forward rate given the forward discount factor. Well, it's an actual over 360 rate. We're going to invert that formula, the discount factor formula, and we find the rate is equal to 1 divided by the discount factor minus 1 times 360. And again, that 360 is because we're looking for an actual over 360 rate. If we were looking for an actual over 365 rate, that would be a 365, divided by the number of days that this rate is valid for. This rate is a rate between 138 and 302 days, so we're going to take 302 minus 138. So 1 over the discount factor minus 1 times 360 divided by the number of days, in this case 302 minus 138. So we get a rate of 7.0208. Again, we've really used a couple of formulas here, right? One of the formulas we used was the discount factor formula. Oops. So 1 divided by 1 plus the rate times days over 360. So that was one formula. We used the forward discount factor formula, df2 equals df1 times df1, and solve for the forward discount factor. And then we use that first formula again to find the rate. We just did some algebra to take the discount factor. We had discount factor equals a function of rate, and we found the rate as a function of the discount factor. And we end up with a rate of 7.0208.